Alright, dear children, now we discuss the last two processes that actually the applications of first law of thermodynamics. Now the next process which is also occurs at a constant pressure is called isobaric process. Now we'll discuss in detail about isobaric process. So when I use the word isobaric, so this baric what is related to barometer, and barometer measure what? Pressure. So isobaric process basically a process takes place at a constant pressure. This is the process which takes place at what? Pressure constant. Constant pressure means the pressure remains constant. Pressure remains constant. Any process in which the pressure remains constant is called isobaric process. Now the work done by the system or work done on the system, so that work done can be positive or it can be negative. Which means under this process, when the pressure remaining constant, definitely work is done by the system or work is done on the system. Because as for the relation of work done by the thermodynamic system is concerned, that is W equals to P d delta B. Work is done when there is a change in volume. Although the pressure remains constant, the volume changes, so work is done by the system or work is done on the system. But children, you know that work done can be positive, it can be what? Negative. Now there are example of isobaric process. Now common example of isobaric process is heating of water in the boiler of steam engine. So take a steam engine, and when you start heating the water, the water start boiling. So the heating of water in the boiler of a steam engine is one of the example of isobaric process. Similarly, formation of steam, the formation of steam from water is also one of the process called isobaric process. Superheating of steam, freezing of water, these are all the example of what? Isobaric process. So freezing of water, freezing of what? Water. Now similarly, formation of steam, like I gave you the example also, the formation of steam, these are all the example of what? Isobaric process. So children, under this process, when some amount of heat is supplied to the system or some amount of heat is given to the system, the volume and the temperature changes. That means under isobaric process, volume and what? Temperature changes. That means these two thermodynamic coordinate changes. That means volume and temperature changes, but the pressure remains constant. And that process is called isobaric process. So children, under isobaric process, if I take as a gas, as a system, then there is a change in temperature. When there is a change in temperature, then there is a change in what energy? Internal energy. Now, this internal energy, change in internal energy under isobaric process can be expressed from first law of thermodynamics. And from first law of thermodynamics, we write Q equals to delta U plus W. See, this is the mathematical equation of first law of thermodynamics. Q equals to delta U plus W. So I'll make delta U as a subject. So delta U equals to Q minus W. Means change in internal energy equals to Q minus W. But you know what is W? That means P delta B. P delta B. So the work is done because there is a change in volume. Although pressure does not change, the volume changes, work is done. So this change in internal energy under isobaric process measure expressed by the relation delta U equals to Q minus P delta B. But as you know that this work done can be positive or negative. So this internal energy which changes can also be positive or negative, depending upon how the internal energy changes. And when the internal energy increases, this internal energy become positive. Change in internal energy become positive. When there is a decrease in internal energy, then internal energy become what? Negative. So it can be positive or negative depending upon the work is done by the system or work is done on the system, and with the increase in internal energy or decrease in internal energy. But keep in mind this much, children, that under isobaric process, what will remain constant? Pressure remain constant. Pressure remain what? Constant. Now we discuss in detail about the last process that is called adiabatic process. And children, adiabatic process is such a process which takes place in such a manner so that there is exchange of heat between system and and surrounding. I mean to say, in this process there is no exchange of heat. So heat cannot go from system to surrounding, or heat never come from surrounding to system. Means there is no exchange of heat between system and surrounding. So under this process, Q is simply 0. So adiabatic process is such a process in which there is no exchange of heat between system and surrounding. Thus, the heat neither enters into the system from the surrounding, and neither the heat leaves from the system to the surrounding, which means Q equals to 0. So this process is called adiabatic process. So under this process also we can write the first of thermodynamics, and the first of thermodynamics is given by the relation Q equals to delta U plus W. So I put Q equals to 0 equals to delta U plus W. So if Q 0 equals to delta U plus W, then I'll make delta U the subject. So W plus W I'll bring to the left hand side. It will minus W equals to delta U, which means delta U equals to minus W. So look at the relation, children. So on the adiabatic process, change in internal energy equals to negative work done. Negative what? Work done. That means delta U equals to minus W. That means under adiabatic process, only the heat will not exchange between system and surrounding, but work is done by the system and work is done on the system. Okay, but as you know, you have learned that if work is done on the system, if work is done on the system, then this work is taken as what? Negative. So when work done is negative, when work is done on the system. That means if I consider this work done is a work done on the system, then this work done is negative. So I follow the sign convention. So under this case, delta U equals to minus, I write this W equals to minus W. So I am following the condition where work is done on the system, so then this work done is negative. So with W means minus sign, whereas there is already minus sign. So this minus now become plus. That means delta U equals to plus W, or you can simply write as W, which means the internal energy increases when work is done on the system. Means there is an increase in what energy? Internal energy of the system under adiabatic process when work is done on the system. Means I write down simply, there is a what? Increase in what energy? Sorry, there is an increase in what energy? Internal energy of the system. So under adiabatic process, the internal energy of the system increases when work is done on the system. Okay, so this is one of the case. But under adiabatic process, work is done by the system also. I write down if work is done by the system. And you know, if work is done by the system, that work is always positive. This work done is positive. That means I write down plus W. That means this W become plus W. So I write down W delta U equals to minus plus W. So I am just following sign convention in this relation, children. This is the general relation under adiabatic process. And this relation that we derive is under this condition, Q equals to 0. So if W is positive when work is done by the system, then delta U equals to minus into plus is minus W. So this relation says that the internal energy of the system decreases. This minus sign says that the internal energy decreases. Internal energy, okay, of the system decreases. So when internal energy of the system decreases under adiabatic process, when work is done by the system. When work is done by the what? System. But one point you need to keep in mind, children, is that when there is an increase in internal energy of the system, the temperature always rises. There is a rise in what? Temperature. Temperature rises. When internal energy increases, temperature rises. Okay. Now, similarly, if the internal energy decreases, there is a temperature, fall in temperature. Temperature decreases. That means temperature decreases, or it means there is a fall in temperature. So fall in temperature occurs when there is an decrease in internal energy, and rise in temperature takes place when there is an increase in what? Internal energy. Children, for this adiabatic process under this two case condition, there are example also. So let me just add some example of this adiabatic process when there is an increase in internal energy and decrease in what? Internal energy. Okay. Now when the internal energy of the system increases, as I said, the temperature of the system rises. So for this we can understand with one example. Now if it shake vigorously a thermos containing hot tea. Suppose you take a thermos plus containing hot tea, and if you just shake vigorously, then what happen? Okay, there is work done on the tea. There is a work done on the tea. Okay, against the what? The force which exert between them. Okay, the layer of the teas. Okay, and this causes the increase in the what energy? Internal energy of the tea. So when the internal energy of the tea which increases without any heat that extend from between the tea and the thermos plus, okay, then the temperature of the tea rises. So the temperature of the tea inside the thermos plus can be rises by just shaking the what? The thermos plus vigorously. So under this case, what happens? The internal energy increases. When internal energy increases, the temperature of the tea also rises. So this is one of the example. Similarly, when the internal energy of the system decreases, as I said, the temperature of the system decreases, or there is a fall in temperature of the system. And this can also be understood with one example. And one of the very common, a good example of this is when a tire burst. Sometimes the running tire burst. So when the tire burst, its air that is present, the air inside the tire expands suddenly into the atmosphere. So it is also one of the adiabatic process. So when the tire bursts, then air expands so rapidly that it cannot take any heat from outside. So if there is no heat taken by the tire or by the tire from outside, that means there is no exchange of heat takes place between the air and the tire. So under this case, what happens? The air does work against the what? External atmosphere at the expense of what energy? Internal energy. Which means there is a decrease in internal energy of the gas, of the system. And when the internal energy decreases, definitely what happens? The temperature falls. So this is also one of the good example of adiabatic process where there is a decrease in what? Internal energy. So children, remember this point. In adiabatic process, the internal energy can be increases or decreases, but that all depend whether the work is done by the system or work is done on the system. But under adiabatic process, when there is an change in the internal energy, either temperature rises or falls. Okay, so this is the detailed explanation of adiabatic process. But children, the detailed explanation of adiabatic and isothermal process even you learn in the next chapter. Okay, thank you so much.